Hi class, how are you today? That's... The learning target for today is to be able to add, subtract, multiply, and divide complex numbers. On the scale, you're a 3 if you can add, subtract, multiply, and divide complex numbers. You're a 2 if you can add, subtract, and multiply complex numbers, so you're not able to divide them. You're a 1 if you can add and subtract complex numbers, and you're a 0 if you cannot add and subtract complex numbers. Let's get started. So what is a complex number? Well, a complex number is something written in the form a plus bi. So that could be 2 plus 3i. That is a complex number. It could be 8 minus 7i. That is a complex number, where b in this case would be negative 7. And those are ways to write complex numbers. And so a is what we call the real part of the complex number, and bi is what we call the imaginary part of the complex number. So a complex number has a real part and an imaginary part. Complex numbers are a combination of the two types of numbers, real and imaginary. All right, now let's learn about adding and subtracting complex numbers. So what we do here is essentially just combine like terms. We group the things that are real and group the things that are imaginary. So we can rewrite this first part as 5 plus 2 plus negative 7i plus 4i. And so we group those things together, the reals together and the imaginary together. So 5 plus 2 is 7, and then negative 7i plus 4i is a negative 3i. And this is our answer. And now for subtracting, pretty much the same thing, but you want to keep in mind that minus sign. So we group the reals, 4 minus 3, and then we'll put a plus here, and then the imaginaries. Negative 8i minus negative 6i. So for the reals, 4 minus 3 is 1. And for the imaginary part, we have negative 8 minus negative 6i. Well, we're subtracting a negative, so that's the same thing as adding a positive. And so now this is negative 8i plus 6i, which will give us negative 2i. And so the answer is 1 minus 2i. All right, so multiplying complex numbers is just like multiplying polynomials, but with one extra step. So just like in multiplying polynomials, we multiply everything on the left times everything on the right. So 2 times 9 is 18. 2 times negative 3i is negative 6i. 4i times 9 is 36i. And 4i times negative 3i is negative 12i squared. And remember, when you have I times I, it's I squared. And so before we go ahead and combine like terms, we need to deal with that I squared. I squared, remember, is negative 1. So we can rewrite this whole thing 18 minus 6i plus 36i, and then negative 12i squared is the same thing as saying negative 12 times negative 1. And so that makes this plus 12. And now we can combine like terms. And normally when we would multiply polynomials like this, we would end up with 3 terms. However, the I squared turns back into a real number, and now we can bring it down to 2 terms, because 18 plus 12 is 30, and negative 6i plus 36i, hey, is also 30, but 30i. And that is our answer. All right, now for dividing complex numbers. So I have 2 examples here, and they're both a little bit different on how to do it. On the first one, we just have 5i in the denominator. And if we have just an imaginary number in the denominator, in this case 5i, all we have to do is multiply the top and the bottom by I. So on top, we distribute the I, and so that will become 4i plus I squared. And on the bottom, it gives us 5i squared. And so remember, I squared is negative 1, so this can be rewritten as 4i minus 1. And on the bottom, that becomes negative 5. And now we need to be able to write this as a complex number in a plus bi form. So let's put together the things that are real and put together the things that are imaginary. And so since this is all being divided by negative 5, each thing is being divided by negative 5. So we've got negative 1 over negative 5. And I put negative 1 first because it's the real portion. This is the a portion of a plus bi. And then plus 4i over negative 5. However, one final step, we can't have a negative in the denominator. So negative 1 over negative 5, that just becomes 1/5, so 1 over 5. And since the second term has just one negative, we can bring that negative out of the denominator and just replace the plus with a minus. So we've got minus 4i over 5. And even more specific, to be a plus bi form would be 1/5 minus 4/5 I, because a is 1/5 and b is negative 4/5. And so this is your answer. On the second one, it's a little bit more tricky. We need to multiply by what's called the conjugate. And whenever you have a full complex number, real and imaginary, in the denominator, we need to multiply by the conjugate. And the conjugate is just the same thing, but with the imaginary part having a different sign. So we're going to multiply the top and the bottom by 3 minus 6i. So this is specifically the imaginary part gets a different sign. Otherwise, it's exactly the same. So on top, we distribute the 2i to everything. So 2i times 3 is 6i, and 2i times negative 6i is negative 12i squared. And on the bottom, and when you multiply something by its conjugate, it is a difference of squares. So this actually comes out to be 9 minus 36i squared. And what I did there was I squared 3 and I squared 6i. You could multiply this out just like we did previously when I was talking about multiplying complex numbers, but it would come out to the same number. So this is just a shorter way to do it. And so now we want to get rid of those I squareds. So on top we have 6i minus or plus 12, because I squared is -1, so that really just changes the sign there. And on the bottom, we have 9 plus 36. Again, I squared becomes -1 and changes the sign. So now on the bottom, 9 plus 36 we can add up. So on top stays exactly the same. And on the bottom, 9 plus 36 is 45. And now we can rewrite this just like we did up above, and we have 12 over 45 plus 6 over 45i. You could have done 6i over 45. It doesn't matter either way, but putting it in a plus bi form looks like this. And then finally, reduce. So 12 over 45, you can divide each of those by 3, and you'll end up with 4 over 15 plus, and on the other side, you're going to end up with, well, 6 and 45 also can both be divided by 3, and so you'll have 2 over 15i. And this is the way that we're going to put it because it's in a plus bi form. Alright, and now time for the sponge activity. I want you to simplify each expression. For number 1, I would like you to subtract those two complex numbers. So we have 4 plus 6i minus -1 plus 2i. On number 2, I'd like you to multiply those two complex numbers. So 2 minus 4i times 3 minus 2i. And on number 3, I would like you to simplify that fraction, or essentially divide those complex numbers. Remember, multiplying by the conjugate. So we have -2i divided by 3 plus 5i. Alright, that's it for this lesson. Once again, please make sure to take notes on the entire lesson, take a picture of everything, submit it all to Google Classroom, and have a good night.